Good day, everyone. This is Yamna Rani from KSRCE. Let's begin by understanding the fundamental concepts of control systems and their importance in engineering and biomedical applications. This presentation introduces the two main types of control systems, open loop and closed loop systems. It explains their working principles, compare their characteristics, highlights their advantage, disadvantages, and discuss their applications in biomedical engineering. Then, here before we explore these systems, let's first understand the objective of this presentation. The main objectives are to understand the concepts of open loop and closed loop control system, learn how they function, compare their performance, and identify their advantages, limitations, and biomedical applications. Now that we know the objectives, let's first understand what a control system actually is. A control system is a system that regulates the operation of a device or process to produce the desired output. It consists of input, controller, process, and output. It is broadly classified into open loop and closed loop system. Next, let's first discuss the simpler type of control system known as open loop system. It operates without using feedback. The output does not influence the input, so the system performs only according to the predefined input. It is simple, economical, and suitable for applications where high accuracy is not essential. So, next, after understanding its concept, let's see how an open loop system operates. In an open loop system, the input signal is processed by the controller and sent to the plant or process to produce the output. Since there is no feedback mechanism, the system cannot detect or correct any error that occurs during operation. Now let's look at the strength and limitations of open loop system. Uh, Here, open loop system are easy to design, inexpensive, requires less maintenance, and provide a faster response. However, they have lower accuracy because they cannot compensate for disturbances or automatically correct errors, making them unsuitable for precision applications. Next, to overcome the limitations of open loop system, let's move on to closed loop control system. So, next the closed loop control system uses feedback to continuously compare the actual output with the desired output. If any difference is detected, the controller automatically adjusts the system, resulting in improved accuracy, stability, and reliability. Let's how feedback helps to improve the performance of a closed loop system. In a closed loop system, the output is continuously monitored by a feedback sensor. The measured output is compared with the desired output, and any error is sent back to the controller, which makes the necessary adjustments to minimize the error and achieve the required performance. So now let's examine the benefits and challenges of feedback control. So here it provides high accuracy, automatic error correction, and stable performance even under varying conditions. However, they are more complex, expensive, consume more power, and require regular maintenance compared to open loop systems. Then, after studying both the systems individually, let's compare them to understand their differences. So here, open loop system are simple, inexpensive, and operate without feedback. But closed loop system use feedback to achieve higher accuracy and better reliability. Although closed loop system are more costly and complex, they preferred for applications require precise control. Next, let's see how these control systems are applied in biomedical engineering. So, open loop systems are commonly used in devices such as infusion pumps and nebulizers where fixed operations is sufficient. In closed loop systems, used in advanced biomedical devices like artificial pancreas systems, cardiac pacemakers, ventilators, and automated anesthesia delivery systems, where continuous monitoring and automatic adjustments are essential. Finally, let's summarize the key concepts discussed in the presentation. So, open loop and closed loop control systems each have unique advantage and applications. Open loop systems are suitable for simple low cost operations, while closed loop systems are preferred in biomedical and industrial applications. Thank you. Let's analyze with the example of some examples. Suppose we have a traffic control. Now, most of the traffic lights that we see, they just operate on a simple algorithm. A program is installed that the lights will change at regular intervals. You know, after a certain period of time, the lights will change from red, yellow to green, like that. Now, of the most traffic control, the traffic control systems, they do not take any surrounding feedback or any other parameters into consideration, such as what is the volume of the traffic at that instant, whether it is high or low, what time it is, whether it is early morning, where and that gas the traffic is usually less because less number of people go outside, whether it is in the in the midday where the rush is high, or also during the evening. And when the traffic is high or at night, so it does not take any other parameters into consideration. So it just operates on the program which is installed. It has to change light at regular intervals after a certain period of time defined in seconds. So if we design, this is an example of an open loop system. It has no feedback path because it is not considering any surrounding feedback. But if we design a traffic control system which takes into account the traffic volume with the help of suitable sensors which measure the we can use various techniques with the help of, there are various examples such as we can use motion sensors or pressure sensors or Doppler effect sensors. There are various, that is very complicated, so I'm not going into that right now. So in order to determine how many cars or how many vehicles are there on the road, depending on that it will adjust the duration between the changing of lights, or at what time the process is going on, whether it is early morning or midday or evening or late night. So if it takes all of that into account and we have programmed it in that way, that it will become a closed loop system. So that will be a little bit difficult, it will become costly, more circuitry will be required. So that is the example of a simple difference between open loop and a closed loop system. Similarly, if we consider a lighting system, basically if the lighting system which we have in our house, we have to open it and we turn it on and off as per our requirement. It is not happening automatic, but if we install automatic lighting system in such a way that after a certain duration it will automatically get turned off, it will automatically get turned on, that will simply either we are doing it by ourselves or until it is happening automatically, that it will become an open loop system. But if it takes into consideration various other parameters such as the time of the day, so if we use a photo detector which detects the intensity of sunlight during the daytime, the traffic light in our house, it will be off because the photo detector will detect the sunlight, send the signal to the microcontroller. So the microcontroller obviously has a set point intensity of light. If that signal is above or below a certain level, the microcontroller will issue a signal with the help of actuator. to turn the light off during the daytime. And as the evening approaches, the photodetector signal, the microcontroller, the set point value will detect whether the signal from the detector is high or low enough to turn the light on. So during the evening, the lights will get automatically turned on, and during early morning or as the morning approaches, the lights will get off. So here we are taking feedback surroundings, environmental feedback, that is the sunlight. So if we employ this mechanism, it will become a closed loop system. By when we do it manually or it just get turns on or off after a certain period of time, then it will become a open loop system. Another example is that during cloudy days, sometimes sunlight is very low even during the daytime. So at that point also, even it is during the daytime and the intensity of sunlight is very less, the microcontroller will detect that and it will issue a signal to turn the light. So that is that becomes closed loop system because it taking the feedback. So this is a simple example of open loop and